Hello everyone and welcome to the next lecture in the course where we're going to be taking a look at files and streams. So let's take a look at the introduction. Storage of data in variables is temporary. When the program is done running or when the program is turned off, that data is gone. Data can be stored permanently, more or less, on secondary storage devices. These can consist of magnetic disks, optical disks, or tapes. Let's look at the data hierarchy. The lowest level of data storage is in binary digits, which consists of zeros and ones. Bits grouped together into bytes. We have bytes grouped into characters, and characters or bytes grouped together to form fields grouped together to form records, and records grouped to form files. When it comes to files and streams, Java views a file as a stream of bytes. A file ends with an end-of-file marker or a specific byte number. The file as a stream of bytes is associated with an object. Java also associates streams with devices. And here's an example. Streams can be redirected. We have file processing with classes in the package java.io. We have file input stream for byte-based input from a file, file output stream for byte-based output to a file, file reader for character-based input from a file, and file writer for character-based output to a file. There is buffering. Buffering improves the performance of the I/O. Buffering copies each output to a region of memory called a buffer. We can send the entire buffer to a disk at once. One long disk access takes less time than many smaller ones. Due to this, repeated head seeks are required. Buffered output stream buffers the file output. Buffered input stream buffers the file input. Let's look at the class file. Here are some methods from the class file. We have Boolean can read. This returns true if a file is readable. If not, it will return false. We have Boolean can write. This returns true if a file is writable. If not, it returns false. Boolean exists returns true if the name specified as the argument to the file constructor is a file or directory in the specified path. If not, again it will return false. Boolean is file returns true if the name specified as the argument to the file constructor is a file, or otherwise false. Boolean is directory returns true if the name specified as the argument to the file constructor is a directory. If not, again it will return false. Boolean is absolute returns true if the arguments specified to the file constructor indicate an absolute path to a file or directory. If not, it will return false. String get absolute path returns a string with the absolute path of the file or directory. Other methods from the class file stand as string get name, which returns a string with the name of the file or directory. String get path returns a string with the path of the file or directory. String get parent returns a string with the parent directory of the file or directory, that is, the directory in which the file or directory can be found. Long length returns the length of the file in bytes. If the file object represents a directory, a 0 is returned. Long-last modified returns a platform-dependent representation of the time at which the file or directory was last modified. The value returned is useful only for comparison with other values returned by this method. String list returns an array of strings representing the contents of a directory. It returns null if the file object is not in a directory. With class file, it creates a GUI with JText field. You enter a file and directory name. JText area displays information. And when it comes to program features, the body of if outputs information about the file if it exists. It creates a reader to gather data from a file. And it can get lists of files in the directory. Creating a sequential access file. Java imposes no structure on a file. The programmer structures the file according to the application. Account record is a class specified and declares the structure for file access examples, such as a node. The class can be compiled into a package, and it implements serializable for use without I/O streams. When it comes to the program, it prepares the GUIs for file access. With Note, a class is compiled as a package. Buttons are provided for actions in later examples. The program in imports the GUI and record classes. The interface and references to the buttons are created. We have a selected file retrieved and opened, the method closeFile to close the current file, data retrieved from text fields, and new record retrieved. A new record retrieved, written to the file. When it comes to reading data from sequential access files, data is stored in files. It can be retrieved for processing when it is needed. When it comes to accessing a sequential file, data must be read in the same format it was written. If we have a note program, we create an instance of an interface. It responds to an open button with a next button. The JFileChooser is used as before, and method readObject reads an object from the object input stream. To read from a file repeatedly, we must close and reopen a file. Each time, print only records which satisfies the condition. This allows inquiries. When it comes to updating a sequential access file, this is difficult due to the fact that an entire file must be rewritten to change one field. This is only acceptable if many records are being updated at once. You can note that this was done in the days of using magnetic tapes. When we look at the characteristics of sequential systems, we have two types of files: master files, which are files with relatively permanent data, and transaction files, which are files of transitory records. Another characteristic is being able to update master files. We can use transaction files, combine or merge old master files with transaction files, create a new master file, or the old master and transaction file are the backup for the new master file. Here is a table of updating master files. As you can see, the old master file and the file transaction are going in to update the program. In the end, we have the exception report and our new master file. A transaction file contains records to be added, modifications to existing records on an old master file, and orders for deletions of records on the old master file. Possible errors that can occur consist of adding, the record for the specified ID already exists, modify, the record does not exist, or delete, the record does not exist. Here is a program flowchart. Let's take a look at random access files. Instant access applications must have the record located immediately, and transaction processing systems require a rapid pace with instant access applications. With random access files, we are able to access individual records directly and quickly. Random access files use fixed length for every record, and it's easy to calculate record locations. It inserts records without destroying other data in a file. Let's continue looking at a random access file. For a random access file, we have objects like data input stream and data output stream. It reads or writes data in a spot specified by a file position pointer. This can manipulate all data as primitive types and normally writes one object at a time to a file. Note is a new class derived from a count record. When trying to read or attempting to read from a random access file, you should read sequentially through the random access file. When opening the random access file, specify the file name with an Open File dialog box. The record is displayed in the Bank UI window. Click on the Next button to view the next record. The try and catch combination handles the end of file. When it comes to a transaction processing program, let's take a look at these 2 points right here. When it comes to the substantial transaction processing system, we can use class with methods for random access files and updates of adds and deleting accounts. With note, we have the creation of a file editor object, handling of the action buttons, creating new records, updating and deleting records, and displaying records in text fields. There is the use of the transaction processor class, and when it comes to features with a transaction processing program, we have it creates the random access file from the name provided, positions the file pointer, reads and edits, repositions the file pointer, and updates the record, and deletes the record by overriding with a blank record. I hope you're enjoying the lectures so far, and I'll see you guys in the next one, as this marks the end of this lecture.